Thank you for joining me for Your Dad Academy. This channel gives you a way to talk to your children about science. So your kids probably know that wood lights on fire very easily. But did they ever think that a peanut lights on fire? Let's try to see if we can get this to go. So we want you to have discussions about science. Why does a peanut light on fire? So join me for Your Dad Academy. This is a new channel where you can have ways to talk to your children about science. When my kids ask science questions, I'm always willing to explain with all of the science. I've been teaching science for 23 years, and so we're going to try to talk about a couple topics on this channel that you can explain to your own kids at home, just using things that you have lying around the house. So the other day, my daughter was talking to me about density and why things float. And so quickly I grabbed a couple things and I showed her a quick demonstration, and we discussed about why things float. So I was having a glass of wine with my wife, and we had opened our wine bottle, and she asked about the cork, and she said it was so cool, and was asking about why things float. And I showed her this floating, and I asked her quite plainly, why does it float? And she didn't really know. And I explained to her that the density of a cork is less than the density of water. Water has a density of 1. The cork has a density of about 0.24, so anything that is less dense than water will float. And so I did that, and then I had a challenge for her, and I asked her about aluminum. Is aluminum more or less dense? And what do you know about aluminum? Does it sink or does it float? And so I quickly dropped something in there and showed her how it sinks. But then I said, what's happening in this situation if you take a paper clip like this, and this is part of the secret of this, is you take it and you make it almost like a forklift, and this is gonna help you lower this one in. And I asked her why, when you have most paper clips, they sink, but when you do this one, like this, why does it float? Okay, so right here, we've dropped a paper clip into the water, so it sank right away. But now we're gonna use this paper clip. I've bent this one so I can just drop it in real easily. So if you go real easily and don't break the surface tension, this one should float. Now to help emphasize this point, I'm gonna put a little bit of pepper on here. And so you can look at the pepper on the surface of the water. But if you're going to break the surface tension, watch what happens to the pepper and watch what happens to the paper clip. All right, the pepper, you can see, went to the sides. And if I put the soap on here, it should spread. Ooh, it didn't do what I had hoped that it would do. Very interesting. So sometimes things don't go exactly the way you planned, but pretty cool. All right, since I didn't get the reaction I wanted with the pepper in the cup, I'm gonna put it on this plate right here and see if I get a better reaction. So I'm just putting some water on this plate, and then we're gonna put some pepper on the surface so you can kind of see it. So the pepper is everywhere on the surface. And so the pepper is floating wherever it wants to float. And then using the soap, we should be able to get the reaction we want. The pepper should spread out to the sides, but not everything works the way that you want it to in science. But that was pretty cool to watch that happen. And so I started talking about some of the properties of water and how the water molecules hold each other together because they are charged, they are polar. so then I also showed her if I mess with the polarity of the water by adding just a little bit of soap, I can break the surface tension and real quickly that paperclip will fall down. So these are all things that you can start and create a discussion for your children at home when they ask questions. And it's always good to bring this up when you have these things lying around. And so the next question is you have two parts of tinfoil. They're about the same size. And so you can ask them, why does this tinfoil sink? Not sinking because why not? And so sometimes in science it doesn't go the way that you hope that it would go. But if I squeeze it down, is it gonna sink or float? And that one is not sinking. And why is it not sinking? Most likely it's because there are air bubbles trapped inside there. But if I take it and make it flat, I'm gonna rip this in half because this is part of the demo. If I take it and fold it flat and make sure that no air bubbles are trapped inside there, what's gonna happen with the aluminum? The aluminum foil is made out of the same material of these paper clips that sank. And so if there's no air trapped inside here, what should it do? And it sinks. But what if I take the same amount right here and I do something like this, or I fold the sides up like this? What's gonna happen? And so if I fold the sides up just a little bit, like this, my tongue is sticking out because I'm working so hard to try to make this happen. All right, get all the sides folded up. All right, you probably know what I'm doing, but by doing this, why does that float? It has the same mass as that aluminum down there, and they might say there's an air bubble trap, but the air is not really trapped, but you can also start holding more stuff in that little boat. It might even be able to hold this other whole piece of tin foil, and it's not the air bubbles inside here. It's probably gonna sink this boat now, but we'll see what happens. And why does it stay floating until eventually it fills with water and then it sinks? Why did it stay floating for that little amount of time before it sank? This one we know the air was trapped in it, but why did the other one sink? Well, it has to do with the displacement of the water pushed out of the way on the sides. And if you can displace more of the water, then you can actually cause the boat to float. And so that's why special aircraft carriers that are made out of concrete and steel that are so giant that you think would sink, they actually float really well. So I'm going to show you some more of the equations and the science, and I'll show you some pictures that explain the density of cork and why it floats. And I'll put those up there, and I hope that you join me next time. I'm going to keep making more videos to explain the science on Your Dad Academy. Thank you for joining me, and I'd like you to subscribe so you can have some more activities to do with your kids at home to teach them the science and get excited about science. Let's look at the math of the density here. So what we do is we find the diameter of the cork with the ruler, and the diameter comes out to be about 1.9 centimeters. With the radius of 0.95, that's half of 1.9 centimeters. So what you do is you find the area of the top circle of the cork. And so area of a circle equals pi times r squared. 3.14 is what is equal to pi, and then you multiply times 0.95 squared. 0.95 squared works out to be about 0.9025, and now the units are centimeters squared. You multiply times 3.14, and you get 2.83 centimeters squared. It's very important to keep these units. And so now you find the volume of the cylinder. The equation for the volume of this cylinder up here is pi r squared, that's what we figured out right here, times the height of the cylinder. So we take our 2.83 centimeters squared and we multiply it times the height, which I've measured to be 5 centimeters. Multiply those out and you get a volume of 14.15 centimeters cubed. This unit's very important because this is used in density. Now the mass of the cork is weighed out to be about 3.4 grams. This is the mass on us. Let's take a quick pause right here so that you can look at the equation for density, use these variables, plug them in, and then try to solve for the density on your own before I show the answer. So again, some teachers teach this little trick. So this is the same equation right here, but written into a triangle. So if I'm solving for density, I can cover the D right here, and you're solving for M divided by V. If I was solving for the volume, I could cover the V and do M divided by D. And if I'm solving for mass, I could cover the M here, and now it's density times volume. That is simple algebra, and I've broken it down into this kind of cheat triangle that you can use for equations like this. And so the equation for density is density equals mass divided by volume. So I take the mass that I have of the cork and I divide by the volume, which is 14.15 centimeters cubed, and you get this answer. The density of the cork is 0.24 grams centimeters cubed. So there we have it, and there's the math to find the density of the cork, and that is less than 1. Water has a density of 1, and that is why the cork floats.